Okay, welcome back. In this part of the video, we'll be tackling a small error we have in the iteration protocol, so in the iteration interface we defined for the hashtag. So that's going to be one part, and the other part we're going to finally upload the repository to GitHub. And so we'll try to set up Travis and other things, or maybe, we'll see. Yeah, it might not be that useful, but in any way we'll at least create the repository for it. Okay, so what do I mean by error in the iteration interface? If you look on the Julia documentation in the iteration interface, so we define iterate and iterate with state, so we define these two methods for both our hashtag and the buckets that it contains. It's supposed to return a tuple of the first item and initial state. So what we return is, so each value, so this, let's make a note on the side, this, or even state this, they both return either nothing or something, which is in that case a tuple with first a value and second the next state. Okay, and in that case the value for us corresponds to a tuple itself, which is key and value. Okay, now so that's how we've defined the iteration. The thing is, so if we look at the traits, so which are special kinds of methods in Julia. So traits just characterize one type, so they describe an object and by its type. So for example, if you provide an iterator type, so our type here, to the iterator size, is gonna give you either has length, which is one description, or is infinite, or size unknown, or has shape. So in our case the default is has length. So if we try this, let's go, so we can close this here. Oh, that we don't need. And so let's go back to the project. So let's using hashtags. So this is one type of hashtag, which is int, and if we do base.iterator size over this is going to give us the kind of size that we can expect from this iterator. In that case it's has length. We keep the default, and has length just says this is a finite bounded iterator. It's not gonna iterate infinitely. Moreover, we can know the size beforehand. So this means for one hashtag, so this is for the type hashtag itself, but for one given hashtag, let's say this one, we can know, we can compute the size. In that case it's just computed with the length function here. Okay, so far so good, we don't have any problem. So this is the first trait. Does it have a size? Does this type of iterator have a size or not? The second one is, does this type of iterator have an element type, an L type? So the default is has L type. It means for a given iterator we can know the type of its elements. And so it's either L type unknown or has L type if we know from the type directly what kind of elements we can expect out of it. So the default L type here is any. For our, if we do this, we don't get any here. We get a pair of string and string. But so that's the first problem. The thing is, I think L type is defined for, base arrays. Okay, that's interesting. I thought this would be defined for dictionaries, or for, let's say, abstract dictionary. If we do code lower to see a bit what's under the hood here, space type of x. Okay, so no, yeah. So if we do L type of the type, so because L type is defined on the type and not on the value. So now this is the which we want. Okay, yeah. So as I thought here, so L type is defined for abstract dictionaries, and the problem is that it's supposed to return a pair of. If we go back here, it's supposed to return a pair of string or pair of k and v. If the hash date is, for example, k and v. So if we do uint8 and string, the L type of this is supposed to be pair of uint8 and string. But the problem is, in the case of our hash date, this is not what iterations are giving us. Let's do an example. So this is uint 8 3 and let's say uint 8 of 1. So this is the same type now. So this is a hash date uint8 string, okay. And now for element in D, so this is iterating over D and getting the elements, and we're gonna just info type, and then we're gonna interpolate the L type, the type of each element, so which is supposed to be the L type here, and we get, oh no, not of D, of course, it's of element. And then we get, that's what we did, we implemented it with a tuple and not with pairs. So this is problematic. So this is saying that an abstract date is supposed to be a collection of pairs, not a collection not a collection of tuples. So that's fairly important. So we do not fulfill the promise of the interface here. This means we can have bugs. And one example of a bug here is, so if you check the method of a function called collect, it's so collect of any collection or iterator is going to get put all these values from the iterator or from the collection into an array, so into a vector. So for dictionaries, oh, it's here. For dictionaries, returns pair, key type, val type. Okay, so this is here. Maybe this piece of documentation could be also in the docstring of abstract dict, because this is defining the promise of what is an abstract dict. If we look now at our source code, we are returning vector of tuples, or we're taking vector of tuples. So here this is an input, so it's not a big deal, but here we're mostly that's interesting. So with the abstraction we have in the code of hashdate, we don't have that many things to replace. Where we really have to replace things is in the basic container, which in our case is the bucket. Okay, so here, that's the biggest thing we have to do here, is replace this vector of tuple with a vector of pair. Okay, and then here oh no, no. Oh no, this is fine, because b item is going to return the pair itself, so it's going to return the good type. And so I think we don't have that many things to change. Well, we'll see if the test pass. It's going to be the first real test. Oh yeah, here. When we're pushing something, Yeah. No, that we can do because we have an automatic conversion from pair, so from the elements of the items, into a destructor tuple k and v. Again, we can show this if we're in the, so if we have a pair, we did this already in the previous video, but we can do kv equals pair, then k is the first value and v is the second value. So this means even with pair instead of tuple, we can do that without any trouble. So here we have, this is one of the only issues we have. We are pushing a tuple. So instead we're just gonna use a nice arrow constructor for pair. So this is a pair here. So this is fine. And then same thing here. If we reset the value. So here we're constructing a pair and pushing it to the elements. So getIndex here is also supposed to return a value, so it's fine. We're just returning a value, and this is the magic conversion working. Same thing here, we're all good. Same thing here. So here, this might be a bit confusing. I'm checking that we don't have a pair. No, we just have pairs as a function, but we're not gonna have any conflict if we write pair. In the numerator it's kv equal pair. It's actually a better name than top, I think. And that's it. The rest of it is fine. Okay, and it seems all the rest of it should be fine. Oh, one thing I wanted to mention, sorry, I completely forgot, is so if we collect, so before any modification, I'm not reloading the code or anything. Let's say so I'm gonna define a base dictionary. I think we did that for, yes. So D2 is gonna be a standard library or base Julia dictionary, and D is gonna be a hashdict, so our custom type. Okay, so what happens if we collect D2? We get an array of pair string string. Okay, so a vector of pair string string. Now if we collect D, what's gonna happen is so the L type is expected to be pair because it's defined on the abstract dict level. So it's gonna create a vector of pairs and then try to fill it with the elements iterated from D. But these elements are not pairs, they're tuples, and so we're gonna get an error. Cannot convert an object of tuple to an object of type pair, or at least not implicitly like this. Yeah. So we cannot. Oh yeah, we can. No, we cannot. Okay. So this means we did not fulfill, let's say, the promise of the interface. So now we fixed it, and so we're gonna rerun the test. So this is gonna reload all our code and attempt to, well, not attempt, just test everything. Okay, we still have some errors. Let's check what's going on. Let's unzoom a bit. No method matching bucket array tuple array of pair. Okay, so we are calling it wrong in the project. Yeah, maybe we should have a conversion, but no, I guess that's not correct. So in that case, it's fairly minor because it's just our tests which need to be updated to say, hey, now we fixed it, so we fulfill the promise, let's say, of the contract of the interface. So we can just add the constructor here. And the rest of it should be fairly fine, I think. Yes. Let's retest. Okay, and everything works fine now. So we now have. Oh, sorry. Yes. So we said that we needed to do this collect thing to get the error. So now I guess we will just add some test again, since we had something failing and the tests were not covering it. It means we need a new test to validate that we are not failing anymore. So D is gonna be no. We're gonna get a real D with yeah. So let's say D is gonna be key int and value strings. Okay. And then so for let's p equals, so we'll take the first, oh no, we'll just iterate over it. So for p in D, so this is now supposed to be not a tuple anymore but a pair. So we're just going to do a very dumb test, which is just test the type. It's not even interesting. We can test yeah, we'll just do it simple. P is a pair. Collect L type bug. So that was a fairly boring one, but then what we can do is we can collect collected equal collect of D. And so this is getting all the elements from D, and this is supposed to return a vector with this and this. So test. So we're gonna test the first two elements. Should we maybe sort them? I'm not sure. No, we cannot assume the order because dictionaries are not ordered at all. So can we sort? So we're gonna sort in place the collected. Yes, sort has to be passed a function. So for key and some value we don't care about, this is we are sorting by key collected. Okay. And once this is sorted, yeah, we could even. Okay, we're just gonna see first. The first test is, does this break or not? Because beforehand this was failing. And then we're sorting by key, and then we are. So the bang is indicating that the sorting is in place. The alternative is to do sort something like sorted collect like this. Okay, but we don't want that here. Okay, so we sort, or we collect, we sort, and now the first element has to be collected one equals. So the first element is supposed to be this pair, second element is supposed to be that pair. Hi. Okay. Oops, let's resume here. Relaunch the project and test. I'm not sure this is the right syntax for sort, so we'll see. Yeah, something's wrong. Okay, what happened? The method matching sort with, let's say, an anonymous function here and an array. Okay. So how do we sort things? Okay, so we have multiple ways of sorting. Let's resume in a bit for you. Okay, sort. Algorithm equals default algorithm. Okay, yeah, by. So I think it's by here. Yes, LT so is the comparison function, and by is how you sort them. So it's what I did is pass the function first as first argument, which is a pretty useful and used convention is in Julia, but sometimes you don't want the function first. So here it's by. So if we modify this, so here, so that would be our sorting function, or the way we sort these elements. So it's passed as a keyword, which is by. So by key basically. I'm gonna check if I didn't have any related function that could be exactly what we are looking for here. No, sort the non-in-place version, the in-place version, sort permutations, and that's it. Okay. So we're gonna leave the standard algorithm here. It doesn't matter that much. Okay. So what do the tests give us now? Okay, still a bug or an error. No method matching var pair. Oh. Maybe this is escaping. Yeah. Oops. Okay. Does this work? Still no. So this is okay. We cannot decompose in the argument of. So this is still a pair, and p dot first. Nope, still not. Expression evaluated to non-boolean. Oh, I think yeah, there's a precedence here. We have to test things like this, because otherwise this is collect this. Yeah, this is performed first. Oh no, this yeah. I think the precedence is changed by the arrow operator, which has some different precedence from other operators. I think it's going right to left. So this is fairly convenient for some things, but not others. Okay, this should be fine now. Okay, yeah, perfect. So we now fix the collect L type bug. Maybe we'll call it something else, because yeah. Collect L type is pair kv. Okay. All right. So we have it now. So we'll just commit that. So the nice thing here, if you notice, we didn't commit to the beginning, and we have just changed a little thing in bucket. If we look at the diff, it's just one thing here, one there, 3, 4, and yeah, 4 little changes, and we've completely changed the underlying memory model of the hash date, but it has not changed anything else. So that's a fairly nice feature we have here. Not vendor's decomposition. It's actually collect L type is pair. Alright, I was about to push, but we don't actually have anything prepared. So this is the second thing we wanted to do. We said so it's creating. So we are done here. I think we have everything defined. Okay. So now we'll create a repository. So I'll do it here. Create a new repository because hash dates, a simple hash map implementation sounds about right. For sure, it's not too complex. We already have a README, git ignore, I think, and a license. So yeah, I'm gonna check for the license, but yes, we do have a license and a README, so we don't need any of these. We'll just create the repo, and from there, just I'm gonna use remote. Oh, I think we defined it because when we created the project with pkg template, we said we wanted to use SSH, and I provided my GitHub user handle, so it already knew what was the right URL for this. If I specified that I wanted to create the project on GitHub, so I'm just gonna pull. Oh yeah, there's no master because we don't have committed anything. We haven't committed anything on master, sorry. And yep, there we go. We now have a hash date with our 14 commits. I think I'll push all the branches, so it will be how do you push all? Yeah, push all, perfect. So we're gonna push all the branches, because I did some branches, not all of them. Yeah, I think I forgot part 3 at some point, but you have part 1, part 2, and part 4, which are on different branches. If you wanna check out one branch to be like, oh, okay, at this point we were here, at this point we're here. Okay. All right. So I think that's in pretty good shape, and we have now our public repository. So the nice thing is we don't have to set up anything, it's just basically all there. The next thing, so if you check here, Travis and codecov are not working yet. So Travis is a continuous integration service, or CI if you read people writing about it on the internet. Oh, and we don't have hashtag yet. I'm not signed in, that's curious. Okay, so I let Travis by Travis Pro. Okay, I don't think I am Travis Pro or anything. Okay, so I'm now logged in. We don't have any hashtag, so we'll just create it. Sync account. Less than a minute ago, so it should all be there. I thought this was already activated. All repository, approve and install. Yeah, it sounds right. Yeah, this is weird. I thought this was all done already. Huh. So I guess we'll have to wait a bit. So this is a whole bunch of projects. Some of them I should probably delete at this point. And we're looking for hashtag, which might be quite at the end. Where is it? Huh. I even get all the hash wrapper. This is we're close. Was it before? Yeah, maybe. Hashtags. There we go. Okay, so let's settings. Alright, this sounds about fine. We don't need anything. More options, trigger build. Yeah, on master. So this is I guess build created successful. Yeah, created, but not. It doesn't mean that it's actually running. Yeah, so master is now running. So if you look on here, what exactly is Travis doing? It's basically creating real-world images and then running, so cloning our package, so getting a whole fresh Julia environment, cloning our package, building it. So in our case, building is just including, so it doesn't make that much work, and then testing it. That's it. And it's doing so on different architectures. Yeah, different architectures when you want, different OSs and different Julia versions. So in my case, I'm just using Julia 1.0, which is supposed to work. Here we didn't use anything above 1.0, I think, even though I use 1.3 as a working version. And then Julia Nightly, just to see, is it working on the latest version of Julia. This is fairly useful if you are on the bleeding edge to be sure that you're not breaking anything or using some features that are gonna be gone in the next releases. Okay, so this is fairly long. Should we maybe move forward? Yeah. In the meantime, I'm not sure what we could do. Oh yeah, we can check what exactly is a Travis file, for those who don't know. So a Travis file it was already defined by pkg template, if you remember the first video. And in this, we're basically declaring how do we want to run all these things, how do we want to test everything. So it's saying the main language here is Julia for this project. We want to test on 2 OSs, so Linux and OS X. We want to test with Julia 1.0, Julia Nightly. We could add Julia 1.3 here, which is the latest one at the time of this video, or the latest stable one. And then, so this is saying if we fail on Julia Nightly, this is okay. So this is maybe not our fault, but the fault of Julia Nightly having a bug or anything. Fast finish is just if we error on a nightly, it's not a big deal. And notification, no, I don't want to get spammed. And after success, this is saying Travis can push to coverage and codecov. To codecov, sorry. So codecov is a service doing code coverage, so saying how much of our source is covered by the current tests. So this is getting this result by running the package with additional information. That's it. Yeah. So this is finished. Great. So I think we're soon gonna have something green here once it updates, and then so Travis is gonna push back to codecov here, and codecov, I'm not sure I'm logged in here. Not even recent commits from. Oh yeah, no. Anyways, we might need. Yeah, we might need to wait quite a bit for this. We're gonna see. So the Linux one is supposed to have push to code coverage. Yeah, this is supposed to have done it. Process cove. This is in fry as a coverage. Okay. So this theoretically pushed everything to here. No, but I'm not sure we're gonna get it this time. So if you the repository is gonna remain online in anyways, so you can see it. Oh, recent commits. Cool. Browse report. Yeah. So I guess this is too sensitive for. Is this a private repository? No. No, this is not. No, still nothing. Okay, no, too bad. So I guess you need more than one commit to get some interesting results here. So that's why. But anyways, we have this working. We're still gonna have a green badge here, and that's about it. We now have a functional package that people can get. So how do you get this package if you're interested in using it? The first thing you can do is just clone it. So in my case, I'm going to get SSH, otherwise it's going to be HTTPS if it's not your package. The second thing is, let's say you're in you're in your Julia project. Let's call it, yeah, let's be super original. So you're in this project, and you generate a project inside this. Let's call it benchmark or benchmarking. So we're gonna go out, cd benchmarkings. So we're now running in this project, and now you want in this project to use a custom dictionary. What you will do is, so if it's registered, you can add hash dict. So in that case, you see you have auto completion, but it's not registered for us. So the only package starting with a hash which is registered is hash IDs. What we can, so if you tab twice, you're gonna get all the packages. I think in auto completion, we don't want that. So how do we do if a package is not registered? Well, you can just use the URL like this, and pkg, so the Julia tool, is going to know that this is a GitHub repository or a Git repository, and we'll try to get it. So download the whole thing and make you run on master. Yeah. So we are now running. So this is in v0.1, but it's not declared. So by default, it's just running on master. Okay. So now if we are in another project which is using hashdict. So if we import hashdict, we get the version that's online at this point. Yeah. And I think that's gonna be it for today. So we're not gonna get. Oh, we are getting code coverage. So I think this might also be here if we refresh. No, not yet. Another. No. So something is not covered. So bucket is not covered completely. So oh yeah, we can check here. I'm always a bit confused here, so I'm not going to be super efficient to look into it. So if we check, hashdict has a pretty good coverage of 89%. We have only 10 misses. It's fine. Bucket is a bit worse. It's still acceptable. It's not dramatic, but we still have some misses in bucket. So let's check it. So this is all the things that have been tested. And then you have some things that are not. So for example, we didn't test that much of a get. We used a function which calls get, but we didn't test get itself, I think. Which is strange. I thought we had at some point with some -1 as a default. But anyways, so ASCII and get are the two black sheeps, let's say, here. And yeah, and here in hashdict, this is one of the constructors is not tested that much. Okay, that's interesting. Return nothing. Okay, we didn't test that this thing returns nothing. That, yeah, great. When is this one reached? When, yeah, oh wait, this one is never supposed to be reached. That's why I'm not sure we can actually test it, because at some point the iterator is supposed to return itself nothing. And yeah, again, get and ASCII, but for the bucket this time. Okay, interesting. Alright, that's about it.